We're going to crack the code on these essential buzzwords so you can start talking tech like a seasoned pro. And hey, to make this a little more interesting, we're not just going to list them out. Nope, we're turning this into a game. We're going to play our way through this entire board, game show style. You ready to play? Kicking things off with round 1, core concepts. All right, here we go for 2 points. Think about infrastructure, where instead of fixing an old server, you just deploy a brand new one. What's that called? And for 1 point, in programming. What do you call data that can never, ever be changed once it's created? You got it? The answer is immutable. Think of it this way. It's like a printed photograph. You can't just go in and edit the photo, right? You have to take a whole new picture. It's the same idea in DevOps. Instead of patching a server that's already running, you just completely replace it with a new, updated one. This is huge because it makes your systems way more predictable and a whole lot more reliable. Okay, next up. This next concept is all about taming complexity. So, what's the principle that lets you use something without having any clue how the messy, complicated stuff inside actually works? This one is everywhere. And that would be abstraction. Honestly, you use abstraction all day, every day. When you get in a car, you just use the steering wheel and the pedals. You don't need to be a mechanic who understands the engine's combustion cycle. In the tech world, abstraction is what lets us use these incredibly powerful cloud services and tools without getting bogged down in every little detail of how they function. It's a lifesaver. All right, let's keep this train rolling. Think about a tool like Terraform. What do we call it when you just describe the end result you want and the tool itself is smart enough to figure out all the steps to make it happen? The term we are looking for is declarative. This is the tell me what you want, not how to get it philosophy. You just write a file that says, hey, I want 3 servers and they should have this software on them, and the tool handles the rest. It's kind of like telling a taxi driver your destination address, not giving them every single turn-by-turn direction to get there. Now, for the total opposite of that, what's the word for when you do spell out every single command step by step? You know, like a super detailed shell script that lists out everything you need to do. And that, my friends, is imperative. This slide just lays it out perfectly. The declarative approach is like the beautiful photo of the finished dish in a cookbook. The imperative approach, that's the super detailed step-by-step recipe that you have to follow to the letter. Now, both have their uses, for sure. But the big trend in DevOps today is definitely moving toward that declarative model. Let's move on to round 2, where we're going to talk about system behavior and architecture. Okay, first clue of the round. This one's all about safety and automation. What's the principle that lets you run a script 1 time or 100 times and get the exact same result every single time without anything blowing up? The answer is idempotent. And let me tell you, this is a massively important idea for automation. It means running a script over and over again is safe. The end state is always the same. It's the difference between a command that says, create this file, which might fail the second time, and a command that says, make sure this file exists. That kind of safety and predictability is pure gold. All right, it is time for an architecture face-off. In this corner, what do we call an application that's built as one giant, inseparable block of code, where even a tiny change means you have to rebuild the whole thing? And in the other corner, what's the architectural style that's made up of a whole bunch of small, totally independent services that all just talk to each other? Got them both? The answers are monolithic and MSA, which stands for microservices architecture. A monolith is like one giant all-in-one factory. It's simple to get started, but if one little machine breaks, the entire factory can grind to a halt. Microservices, on the other hand, are like a whole network of small, specialized workshops. Yeah, they're more complex to set up and coordinate, but you can upgrade or fix one workshop without shutting down all the others. Okay, time for a concept that is, well, it's pretty much the engine of all modern DevOps. What do we call the practice of automating the entire journey of software from the moment a developer writes a line of code all the way to it getting into the hands of a user? And of course, that's CI/CD. It stands for continuous integration and continuous delivery or deployment. This slide shows the flow perfectly. A developer commits their code, which automatically triggers a build, which then automatically runs a bunch of tests, and finally, if everything passes, it gets deployed automatically. It's all about moving fast, but doing it safely, all thanks to automation. Final round. The stakes are high. This is Final Jeopardy. Just one more concept to make you a true pro. Okay, here it is. your final Jeopardy clue. It's a data design pattern. What do you call it when you use the right database for the right job? Like, maybe you use a relational database for your user data, but a completely different document database for your product catalog, all in the same application. And the answer is polyglot persistence. It sounds fancy, but it's simple. Polyglot just means knowing many languages. In this case, it means your application speaks to many different kinds of databases. It's the ultimate right tool for the right job philosophy, but applied to how you store your data. It's an incredibly powerful pattern, especially when you're working with microservices. And that is a wrap on DevOps Jeopardy. Just take a look at that list. You've just added a whole new set of tools to your vocabulary. Immutable, abstraction, declarative, idempotent, CI/CD. The list goes on. And remember, you didn't just learn a bunch of buzzwords, you learned the core ideas that are shaping how all modern software gets built and run. So I'll leave you with this one last question. You've got the vocabulary now, you get the concepts. So the next time you're whiteboarding a new project or architecting a new system, which one of these powerful ideas will you use to bring your next big thing to life? Thanks so much for playing along.